Bright Tuty. Every student matters.
Hello students, so let us start with the first question. First question is of 1 mark basically, and it asks what is pressure. Whenever you are asked to write the definition, first of all you will write the formula, right? Now you will easily remember the definition. The definition is the force acting per unit area is called as pressure. The force that is acting on certain area is known as pressure, right? If A is put is equal to 1, if area is 1 unit, then pressure will be equal to force. So this is the definition. The force acting per unit area is called pressure, right? Now how are pressure and area related to each other? Basically pressure is inversely proportional to area. Inversely proportional to each other. Basically when area is increased, pressure decreases, and when area is decreased, pressure increases. This is the relationship between area and pressure. And also, if you have to give an example, you can give the example of straps of a bag, right? When you have thick straps, area is increased and pressure is decreased, and when you have thin straps, area is decreased and pressure is increased. Simple. This was a 3-mark question basically. You will have to explain writing all the long statements. I have explained you in brief, but you will be writing the whole explanation in detail. Next, this question might come in your exam. That is why I have categorized it in a different question. Bags with thick straps are much more comfortable than the bags with thin straps. Explain why. Here, basically, by using thick straps, we have increased the area of contact between the shoulder and the bag, right? Now by increasing the area, we have reduced the pressure acting on the shoulder due to the weight, or you can say force applied due to the weight of the bag, as pressure is inversely proportional to area. Basically pressure is inversely proportional to area is the main point of recognition here, that if pressure is increased, the area is decreased, right? So when there are thin straps, the area of contact is reduced, so the pressure is increased. That is why you feel more pressure when you have thin strap bag, right? When you have a thin strapped bag, you feel more pressure, while when you have a thick strapped bag, it feels much more comfortable due to the reduction of pressure, right?
Liquids and gases exert pressure on the walls of a container. Explain with the help of activities. So for the liquid, which activity will you prefer? You will be referring to 2 activities. The first activity being where you take cylindrical tube and you fix a balloon on the end of it, right? When the level of water is this much, the balloon is this much inflated. When you increase the level of water, the balloon's volume is increased even more, right? So basically, from here you can tell liquids exert pressure at the bottom of the container, right? Now for sides, you take that bottle example where you have a cylindrical tube attached to it and you have balloon here. When you pour water, the volume of the balloon increases. This is because the liquid is exerting pressure on the walls as well, right? Now for balloons, basically you have a simple balloon, then you have inflated balloon, right? And then you have a fully inflated balloon, right? So a normal balloon, when you inflate it, and if you lose it open, when you leave it open, the air suddenly escapes out. Then it comes to the normal phase, right? Why is this? Because the gas present inside it is applying pressure on the surface of the balloon, because balloon is acting as a container, right? So the gas present inside it is exerting pressure, and if you inflate it to the extent from which it can bear the gas, from where it cannot bear the gas anymore, it bursts as well because the pressure is too much. So this is how we can tell that liquids and gases exert pressure on the walls of their container, right? Next question. What will you observe if you cut out a bottle at 3 spots present at the same height and pour water into it? Basically, you have a bottle and you have chosen this height. The first hole is here, second hole is here, and third hole is here. When you cut out 3 holes at the same depth from the ground, what do you see? The water falling from the bottle falls at the same distance. This distance and this distance is equal. So basically, the water falls out at the same distance, and this tells us that the pressure applied on all the 3 spots is equal because their depth is equal. When you have poured water into it, the water coming out of these 3 spots will be equal because they are present at the same height. So the pressure exerted on all the 3 spots is equal due to the same height of all these spots, right?
What is atmospheric pressure? This is simply a 1-mark question. Atmospheric pressure is the pressure exerted by the atmosphere on the surface of the earth. You can draw a diagram as well. This is the earth. You can draw it more spherical, and this is the atmosphere. It applies some pressure on the surface of the earth, which is the atmospheric pressure, right? Now, how can we calculate atmospheric pressure? As we discussed, we have to take a unit area and we have to fix a tube, right? This is the unit area, and this cylindrical tube has height equal to the atmosphere. So the particles present inside this tube, these particles contribute to the pressure exerted by the atmosphere. Basically the particles, the mass of the particles contributes to the pressure exerted by the atmosphere, and this pressure exerted basically is equal to the force of gravity acting on a 225 kg heavy body, and this force is equal to 2250 newtons, as we have calculated in the lecture. If this area is taken to be as 15 into 15 centimeter square, which is equal to 225 centimeter square, then the atmospheric pressure acting on this much area will be equal to 2250 Newton, which is very high, right? So this is how we calculate the atmospheric pressure. Next question, why are we not crushed due to the atmospheric pressure? As we know, atmospheric pressure, the force applied by atmospheric pressure is equal to 2250 Newton. Then why are we not crushed? Because the pressure in our body is equal to the atmospheric pressure. Hence, they both balance each other and we are not crushed due to the atmospheric pressure, right? So because the pressure inside our bodies is equal to the atmospheric pressure, we are not crushed under it, right? Thank you for your attention, students.